Hello, I'm Andreas, your tech-curious web designer. This is a new tutorial series all about Docker, which is a tool designed to simplify the process of developing, managing and deploying applications using containers. That said, setting up Docker and working with it is not always the easiest thing to do, as it adds more complexity to a project, which, if the project is small and simple, or you develop by yourself, is not always necessary. However, this technology is used almost everywhere in the web developing world, so it's always a good thing to know anyway. In this video, I will give you a quick introduction to Docker, Docker images and Docker containers, what they are and how they work, and we will Dockerize also a basic Django application. But before we get started, a quick shout out to my newest supporter on Patreon. A high five to Juanito. Thank you so much for your support. I really appreciate it. Okay, and now without further ado, let's dive in. So, why should we use Docker? With Docker, we can run our application within an isolated, self-sufficient container that includes all the dependencies and commands needed to run the application, as well as the operating system, which by default is Linux. The benefit of this is that when we share the application with others, they will have the exact same environment as we do, solving the compatibility problem. It also simplifies the deployment, because it can include all the commands we need to successfully deploy the application. Now let's take a look how a workflow to create a Dockerized application looks like. So we have our main application, which is also called the host app. This application typically runs inside a virtual environment to manage its dependencies. As first step, we create a Dockerfile, which includes all the configurations and instructions needed to build a Dockerized application. When we run the docker build command, Docker creates a Docker image using the Dockerfile. This image is a blueprint that defines how the app works, including the application code, operating system, dependencies, and configurations. When we run the docker run command, Docker uses this image to create and start a Docker container. This container is running an instance of the image. You can think of the Docker image like a class and the container like an instance of that class. To see our app in action, we would open a client, such as a web browser, and navigate to the localhost with the port 8000. Django is listening on this port for incoming HTTP requests. To access a Dockerized app, we need to open a port also on the container itself, so that the container can communicate with the outside. This is done using port mapping, where we map the port used by the browser with the container port. Now, if we want to change some code in our application, we would typically do that in our host application, as we do not have direct access to the Dockerized application. To reflect these changes in the running container, we would need to rebuild the Docker image using the docker build command again. However, for development, we can also use Docker volumes, which synchronize the host code with the running container to display the changes immediately. This, however, is not reflected in the Docker image itself, which is a static snapshot of the application when it was first created. So therefore, before sharing the Docker image with others, it is important to rebuild the image to ensure it includes the latest changes. Alright, this is a quick overview of the Docker workflow. Now let's get into the code. So, as we're working with a Django application here, you need to have Python installed and also a code editor. My preferred editor is Visual Studio Code. Here, as you can see, I'm inside a folder called Docker, where I have installed a basic Django application. You can grab this code for this application from my GitHub repository at github.com/andyjudd/django-starter. And with Python manage to py run server, we start the application. And to see it running in the browser, we go to localhost /8000. Okay, this is my basic Django application, which serves as a host application in this tutorial. Let's containerize it now. For this we need to install Docker. So let's go to docker.com. And here download the version for your operating system. I am working on a Mac, so I download here the Mac version. This gives you the Docker desktop application. So here we can see the containers and the images we have created. Okay, let's create our first Docker image. So I go to my project root and create a new file. And the name of this file is Dockerfile. Just like that, without any extension. So in this Docker file we add now our configurations. First we install Python, and the line from Python 3 means we want to install a Docker image including the latest version of Python 3 as well as Linux for the operating system. We will extend this base image by adding our own configuration and instructions. This image is downloaded from the Docker Hub, which is an online library of all the official Docker images. There are many Python images available, and because I'm using Python 3.11 in my project, I will download that image specifically. We could further choose a slim and lightweight version of it. A popular, for example, is Alpine Linux, with just a few megabytes in size, whereas other Linux-based images could be several hundred megabytes. Alpine, however, comes with a few limitations, so it might not always be the best choice for your project. Let's take a quick look at the Docker Hub to see more Docker images for Python. So it's hub.docker.com. This site hosts all the official Docker images. And let's search here for Python. And as we can see, these are all different Python images we can download. So Bookworm refers to a Linux version, as well as Bullseye. We can see here Alpine, which is a lightweight version, and many more. Under the Tag tab here, we see more information about the images, for example the size. And the normal Python image is around 365 megabyte. Whereas the slim version is only 46 megabyte. And Alpine even under 20 megabyte. So depending on the requirements of your project, there are many images available to choose. For my project, I choose the normal image with the specific Python version. Okay, like that. The next two settings I'm going to add are not strictly necessary, but they improve the Python performance in a Docker container. So the first one is the container environment variable, Python do not write bytecode, and set it to 1. This prevents Django from writing PYC files inside the container, which are not necessary. And the other one is Python unbuffered, also set to 1. This sends logs to the container console without buffering, so in real time, which is a much better user experience. Those two settings are typically added to every Python Docker file. Now let's go into the specific settings for our project. So first we define here the work directory. This is the folder within the container for all our application code. You can name this directory whatever you prefer, but a widely used one is the short and simple app. Next is the copy command to copy the requirements.txt file from the host application over to this directory. The dot here stands for this directory. You can also write it like /, that's the same thing, or you can write /app as well. They all target the current work directory. I like to use just a dot. Like that. Okay. So once we have the requirements.txt file in the container, I'm running now the installation. So as first I run the pip install upgrade pip command to have the latest pip version. And then I'm running pip install -r for requirements and then the requirements.txt file. So with this command, we install now all our dependencies. Then with the line copy ... note there is a space between the dots. I copy all the rest of the files from the host application over to this directory in the container. So the first dot represents the source of the host application and the second the app folder in the container. Again, here you can say /app to specify the work directory by name. Then we can add this line to expose the port at number 8000. However, this is not strictly necessary, as we still need to add the port mapping in the run command, but it is a good practice to add it anyway. And last but not least, I add here the run command to run the application. And this command, python manage.py run server, is specified here as a JSON array. And as last argument, we also add the port. So 0000 means that the server inside the container will accept connections on all network interfaces within the container. And by exposing and mapping port 8000, this configuration allows the server to be accessible through port 8000 from outside the container. Okay, this is a very basic Dockerfile. Next, I will create a dockerignore file, because there are some files and folders we do not need inside the container and should not be copied over. This file looks pretty much like a git ignore file. So I create a new file here, .dockerignore. And here I write the files and folders I don't want to copy over to the container, such as the env file, where we store the environment variables, which should never be exposed. We also don't need the venv folder, because we install the dependencies inside the container. Then the Dockerfile itself, we only need it to build the image. And the ds store is only a Mac specific file. If you're not working on a Mac, you can ignore this one. Okay, this is our dockerignore file. Let's save it. And now let's build our Docker image. For this, I open a new terminal because I let the host application keep running in this one. I rename it to Docker. Then I add the command docker build. Next, we name the Docker image with the T flag, -T. So T here stands for tag. And I call this image my Docker image. If we don't give it a name, Docker will just create a random name for it. And as last, I need to specify where my Docker file is saved. So I add here the dot for this root directory. Okay, and then enter. The image is being built now. So the build was really fast, only 1.4 seconds. That's because I did this build before and my base image was already downloaded. Your first build might take well over 1 minute, depending on the base image you're using. Alright, we created our image now. To see this image, we can go to the Docker desktop. Here we go to the images, and here we see the image with the name my Docker image. And here we can also see the size of this image, which is whopping 1 GB. And a big chunk of it is the base image we have used. So choosing a lightweight version can significantly reduce the size of it. We can also check in the terminal here if the image was created with Docker images. Also here we can see the image with the size. Alright. So we created now basically a blueprint of our application. And to run it, we need to create a container. And the command to run a container is docker run I add here this -d flag. This stands for detached and means I let the container run in the background, so I can still access the terminal. However, if you want to inspect the building logs, you can also leave it out. Then I give my Docker container a name with --name, and I call it my Docker container. Then we have to specify the port with -p. 8001 will be my port in the browser. I'm using already port 8000 for my host application, so to have both applications running at the same time, I have to choose a different port. And this browser port I'm mapping now to the container port, which we exposed at port 8000. And as last, I specify the image I want to run. So my Docker image. Okay, this is the command to run the container. And just like that, our container is up and running. We can have a look in the Docker desktop. We can see here that our image is in use now. And under containers, we see our container running. It's using my Docker image and is running on port 8001. We can click on this link. And this is now our running Dockerized app. It is running on port 8001. And our host app is running on 8000. Nice.
Nice.
So these are two isolated instances of the app right now. So if I make a change on the host application here, it will not be reflected in the Dockerized app running inside the container. Let's test this. I quickly change the background color of the header. So I'm going to Templates, Includes and Header, and change the color here to teal 500. And save. So if I refresh the app inside the container, nothing has changed, but my host application has the change. So to synchronize between those two versions, we can use Docker volumes. And one way to do that is to add a volumes parameter straight to the container's run command. For this, I first have to stop and remove the container we built. We can do that with docker stop and then the name of the container. And with docker rm, which stands for remove, I remove the container. These are the two commands we can run in a terminal, but we can do it also very simply in the Docker desktop. So I can just click here the bin icon to remove the container. Alright, now let's run the command again with the volumes parameter. So if docker run in detached mode, then the name of the Docker container, then we can add the volumes, -v. Here we declare first the source, which in my case is the root directory in the host application. So I add here the dot, colon, and mount this to the app folder within the container. /app. So this synchronizes now all the changes in the host application with the app folder in the Docker container. Okay, then again we add the port and the name of the image. My Docker image. Okay. A new container is up and running. Let's check it out. I'm switching to the Dockerized app in the container and refresh. And as we can see, it is now reflecting the color change. Let's test with another color. This time to purple. And save. Now refresh my container application. And it is purple now. Awesome. As well as my host application. Nice. Now this command to run the container is quite long with many parameters. Another way to run this container is by using a Docker Compose file. With a Docker Compose file, we can run many services with just one command. So it is a very useful file when our app is connected to multiple services, such as a Postgres database, Redis or Celery. We will look into this in a future video. But for now, I just use it to run my standalone Django app. So in my root, I create a new file, the docker-compose YAML file with a YML extension. A YAML file is a basic text file which uses indentations similar to Python. It is often used for configuration files. First, I will give here my project a name. If we don't specify a name, it will take the name of the folder, in my case Docker. Then we define here the services of this project. I call my Django application simply app. You can call it whatever you prefer. This is just an identifier used within this Docker Compose file. Then here I specify what Docker image I want to use. Then I can give here the container a name. And again, I will call this container my Docker container. Then I define here the ports. So again, in my local host, the port is 1001 and 8000 is the port of the Docker container. And lastly, I add the volumes configuration, which synchronizes the root directory of the host app with the app folder in the container. Alright, this is a very simple Docker Compose file to run my Dockerized application. Let's save this file. Then I will delete again the current container. So I delete my Docker container. And the command to run a container from a Docker Compose file is docker compose app. And -d for detached. You might still see the docker-compose command still in use. But this command is for the old version of Docker Compose. The current version is version 2. You can see this when you go to the About section in the Docker desktop application. We see here version 2, which uses the command with a space instead of the dash. Okay, this is the whole command we have to run now. Alright, the container was created and started. Let's check it out. And as we can see, it created my Docker container and it's running and is placed inside a project folder, which I named my Docker project. So as mentioned, with Docker Compose, we can have many services now running within this project. We will dive deeper into this topic in a future video. But for now, this is all for this time. Thank you so much for watching. In the next video, we will learn how to Dockerize a Postgres database, so we can easily install and work with a Postgres database locally. I hope to see you there. Until then, stay curious, my friends, and bye bye for now.